America's newest strike fighter, the state-of-the-art F-35 Lightning II, is one of the most technologically advanced aircraft ever built.
In order to build the Joint Strike Fighter, there was going to be more machining that needed to be done of titanium on those airplanes than had essentially been done in the history of the world before. Titanium is difficult to machine because it's very, very hard, and it also has a very low thermal conductivity.
So you have to machine with slower speeds and lighter depths of cut, which actually ends up costing you money because you're going slower.
In 2002, Criari, a small business located in Hanover, New Hampshire that specializes in research and development, began investigating methods for improving the titanium machining cooling process.
We had a small business innovation research grant from the EPA. The main objective of that particular program initially was to remove coolants from cutting operations, which tend to have a lot of biohazards associated with them.
The answer, cooling the cutting operation with liquid nitrogen, the byproduct of which is a harmless gas.
Very early on in this program, we found that having a high liquid fraction of liquid nitrogen at the cutting edge was really effective for removing heat. The real trick is figuring out how to get it there from a fixed source or from wherever you're getting it from through your machine tool. And so we had to come up with a unique technology, what we call our through-spindle lance, to route liquid nitrogen from the top of the spindle to the top of the tool holder, basically, and do it in a dynamic way. Developing that through-spindle lance was key for integrating the technology. It turned out that our initial system that was built during that time period significantly outperformed standard flood cooling. And so because of that, we began to think about other applications of the technology, because now you not only have a prevention benefit, but you have a processing speed benefit.
The SBIR process was instrumental in making the cryogenic machining a success. We used that funding to help develop the initial idea and then also to spread the concept into different applications that could benefit from the same advantages of the machining technique.
In 2009, MAGS signed an exclusive license agreement with Criari so that we could apply it to our machine tools. We spent the next few years developing and integrating that technology into our machine tools. In 2013, MAGS sold, and as part of the sale, a few technologies were retained and spun off to a company called 5ME.
Now 5ME as an independent company can put it on any machine, anywhere. And just last year, they actually purchased the patents from Criari, so they own the technology. They're working with some of the major players in the machining industry to try and bring a more broad base of available tooling, for example, to bear, so people like Lockheed Martin can implement it broadly and throughout their manufacturing base.
Lockheed Martin is using the technology to really drive affordability in their F-35 Joint Strike Fighter program by reducing component cost up to 30%. That is a total of $300 million for the program.
Where we actually did one-to-one comparisons at a Tier 1 supplier for F-35 of flood cooling and liquid nitrogen, and we were able to clearly show that using cryogenics was a big win, both in terms of cost and quality for titanium machining.
We've developed a very sophisticated delivery system. It is machine tool friendly. It'll run through conventional and new machine tools without allowing the cold to dissipate into any other member of the machine tool. The second, and possibly even more important from a performance perspective, is the tooling technology that was developed to handle internal cryogenic flow.
We designed the tools from scratch. With the retrofit kits that 5ME supplies, it offers the end user the flexibility to use through the tool liquid nitrogen coolant or external flood coolant. That's important depending on the type of material that the customer may want to process. The vision for cryogenic machining technology is to replace the conventional coolants that are used today in industry, as well as machine the new, stronger, lighter materials as efficiently as the materials they replace, and then promote a green, clean, and safe work environment. I think what the technology will do is it'll allow the material producers to produce materials that have not been previously developed because of the limitation in machining.